All right, today we are pulling back the curtain on the hidden giants that power our world. We're talking about the Transformers checkup, and really what it takes to keep all of our lights on.
When you flip a switch, you probably picture some huge power plant miles and miles away. But think about it. What's the most important link between that plant and your living room? What really makes sure the power gets where it needs to go every single second of every day?
Well, the answer is this incredible piece of engineering right here, the power transformer. These things are massive, and they are the absolute backbone of our electrical grid. Think of them as the heart of our modern society's circulatory system, pumping electricity safely and efficiently. They are, without a doubt, the grid's unsung heroes.
But here's the thing. As strong as they are, they're not invincible. And when one of these giants fails, it's not just a small problem. We're talking catastrophic. The lights go out, sure, but businesses grind to a halt, and the ripple effects can be absolutely devastating.
So let's really dig in and get to know this unsung hero, because it's so important to understand exactly what's at stake here. These aren't just big metal boxes full of wires. Our entire way of life literally depends on them.
And the cost of a failure, it's just immense. And it's not just about the price of a new transformer. A single failure can set off this whole chain of reaction of costs. We're talking property damage, millions in lost revenue for businesses that are suddenly dark, and then huge bills for environmental cleanup. The stakes just could not be higher. So how in the world do we stop these disasters from happening? Well, for a long time, the approach was pretty simple, but honestly, not always that effective. Now, the whole industry is making a huge shift to a much, much smarter way of keeping these giants healthy. And this really shows that fundamental shift. The old way, time-based maintenance, it's kind of like changing your car's oil every 3,000 miles, no matter what. It's a routine, sure, but you might be wasting money doing it too often, or even worse, you could miss a serious engine problem that's brewing between those scheduled changes. The new way, condition-based, is like having a smart sensor in your car that actually tells you, hey, your oil is starting to break down, you need to change it now. It's predictive, it's precise, and it is so much more effective. And look, this isn't just some idea floating around. It is a massive trend across the entire industry. When you ask grid operators, the answer is crystal clear. The future is all about more condition-based maintenance, more real-time online monitoring, and a big, big move away from those old, rigid schedules. The takeaway here? Data is king. So this data-driven future brings us to this really revolutionary idea. What if we could actually listen to the machine in real time? Well, that's where online monitoring comes in, and believe me, it completely changes the game. So what exactly is continuous online monitoring? Honestly, the best way to think about it is like putting a Fitbit on the transformer. You attach these smart sensors and intelligent devices to it while it's running, and they constantly measure its vital signs, streaming all that data back to the engineers. It's like getting a continuous 24/7 health report. And the benefits here are just huge. This constant flow of data means engineers can spot the absolute earliest warning signs of a problem long before it has a chance to turn into a disaster. That right there dramatically cuts the risk of those catastrophic failures we were talking about. It also lets them keep a super close eye on older, more fragile units that they just can't afford to take offline. And it saves a ton of money by cutting down on expensive and disruptive manual tests. Okay, so we're listening to the machine. That's great. But what exactly are we listening for? Let's dive into the incredible science behind how you actually give a transformer a health check. Now, here is the key to understanding all of this. It's a simple analogy. The special insulating oil inside every transformer, just think of it as its bloodstream. It circulates everywhere inside, and just like our blood, it carries vital information about the health of the entire system. And that brings us to the single most important diagnostic tool there is. It's basically a blood test called dissolved gas analysis, or DGA. Here's how it works. When something starts to go wrong inside, like a connection gets too hot, that stress physically breaks down the oil and creates specific gases. These gases then dissolve into the oil, acting just like a disease marker in our blood. Then, sensors can detect those gases, and get this, based on the unique signature of which gases are there and how much, experts can tell you the exact type of problem developing. It's just brilliant. But DAGA is just one part of the whole checkup. I mean, engineers run a whole panel of tests on this oil blood. They'll check its breakdown voltage to look for contamination. They measure water content because moisture is the mortal enemy of insulation.
They test for acidity, which tells them the oil is getting old, and they measure something called the dissipation factor to check for overall decay. It is a truly comprehensive physical.
And this science gets incredibly precise. It's not just the oil, they're also tracking the health of the special paper insulation inside. Its strength is measured by its degree of polymerization, or DP. Brand new paper has a DP of around 1,000, but when that number drops down to between 150 and 250, that paper becomes brittle. It's at an extremely high risk of just failing. Knowing that number is like a doctor knowing a patient's final prognosis.
And we just can't forget the human element in all of this. None of this is fully automated. All these tests, all this maintenance, it's done by highly skilled technicians who are working in some pretty hazardous environments. They have to follow incredibly strict safety rules to manage everything from high voltage to mechanical dangers. Their expertise is what truly makes all of this possible. So, you put it all together, and what does it all mean? Well, it's a fundamental change in how we look after our most critical infrastructure, and it's all pointing to a future that is more reliable than ever before.
Really, what this means is we've moved away from a rigid, one-way maintenance schedule to a living, breathing, two-way conversation with the machine. By constantly listening to its health, we can step in at the exact right moment, making sure the grid that we all depend on for literally everything in our lives stays stable, reliable, and safe.
And that kind of brings us to one last thought. We're making our grids smarter every single day. But as it gets more complex, with renewables, EVs, all these new demands, the challenge of protecting it just gets bigger. So the question I want to leave you with is this. What's the next frontier in keeping these absolutely essential systems safe?